Okay, so let's go back to math 11 for a sec here. We have a quadratic function. What are the x-intercepts of this graph? What are the x-intercepts? There you go. -2 and +3. If you factor it, you get x plus 2, x minus 3. Therefore, it has zeros of
-3. No, it's -2 and +1.
-2 and +3. Right? What makes each bracket 0? You said 2 and -3.
Oh, that's my bad.
And the equation, blah, 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 equals 0, has roots of
-2 and 3.
-2 and 3. They're all the same thing. Roots, x-intercepts, zeros, they all mean the same thing. The x-intercepts are when you have a graph. The zeros are when you set each bracket equal to 0. And the roots are when you're solving the equation already set to 0. Okay? They all mean the same thing, though. All right? So you'll see those words interchanged. I guess we might as well fill this out. So the zeros of the function, the x-intercepts of the graph, and the roots of the corresponding equation y is equal to 0 are the same numbers. Okay, blah, whatever. All right. So we know that if I have the function x squared plus 5x minus 24, and you factor it, you get x plus 8x minus 3, correct? What multiplies -24, adds to 5, 8, -3. Okay, so the zeros of this polynomial function are -8 and 3. -8 and +3.
Yeah, no, it's so good.
That's not what you said. What do you notice about the constant term in the original and the zeros of the function, of the factored form? Yeah. If you multiply them together, you get that number, right? Correct? That's what we've been doing, factoring, since you learned it in grade 10 or 9 or whenever you learned it. So 24 is a multiple of 8 and 3. -8 and 3. Okay. Okay, so now if I extend this to a trinomial, or a cubic function, the factors of this cubic function are x minus 2, x minus 1, x plus 1. What are the zeros of this? 2 and plus minus 1. Okay. What do you notice about those and this number? They are, if you ignore the sign's kind of irrelevant here. But the constant term and the factors of the polynomial are related. Basically, the zeros or the zeros are the factors of the constant term. That's what I'm trying to say. Okay? So the zeros of the function are factors of the constant term, i.e., whatever your x-intercepts or zeros are, if you multiply them all together, you will get whatever the constant term was of the original function, which is in quadratics, we do that all the time. We just don't think about it. My zeros are 8 and 3. If I multiply those together, I get 24. Okay? So why is this important that you recognize that this applies to higher order functions too? If you flip the page, oh, there we go. Okay, so if I give you a function, x cubed minus 7x minus 6, and I say factor it, okay? What do you do? When you're given a quadratic, if I give you this quadratic, if I give you that quadratic and I say factor it, what do you do in your head?
You find what multiplies to 6 and adds to 5.
You find what multiplies to this and adds to that. That's how you do it, okay? But if I give you a cubic, how do you find the factors? How do you factor it? Well, first of all, you have to know that it's a factor if the yeah, but what do you start with? That's the whole point here, right? You don't know what to start with. So we're trying to figure out what you start with, okay, guys? So to figure out what you start with, you go to the constant term, and you say, what are all the factors of the constant term? What multiplies to the constant term? 2 and 3 is one of them.
1 and 6.
And 1 and 6 is the other one. And you have to put plus or minus because you can combine them in any way you want, right? So you have to put plus or minus. So these are the potential factors, or they are factors of negative 6, but they're the potential factors of this polynomial, okay? So all you do is you look at the constant term and you find all the factors. Now, to write them in as a factor or 0, you let me go down here. So the potential zeros, the potential factors, that means brackets. Write them as brackets. Okay? Now you could do this. You could go x plus 1, x minus 1, x plus 2, x minus 2, and you could do that. For me, all you have to do is go, just say x plus minus 1, okay? It'll cut the amount of stuff you have to write down in half. X plus minus 2, you gotta do the 3, x plus minus 3, and x plus minus 4. That means there are 8 actual possible 6, not 4. I don't know why I said 4. There are 8 possible factors, okay? Because it could be the positive one or the negative one, the positive 2 or the negative 2, et cetera, et cetera, et cetera. So there's 8 possible factors of this function. How do you know which one is a factor?
What adds to 6?
No, it has nothing to do with the middle term. When the remainder equals 0, right? That's what we did in just the lesson we just finished. So how do you find the remainder? Synthetic division, or you plug in your a value. Okay? A value is what makes each bracket 0. Okay? So to find the actual factor, the remainder must equal 0. That's how you find the actual factor. This is how you get all the potential factors, and then we have to use the previous lesson, the remainder theorem or the factor theorem, to find out which one actually is a factor. Okay? So this is what we're going to do on the next page. Once you got that written down, flip the page. And we're going to factor a 4th degree polynomial. We're not doing any of that stuff. Ugh. We're going to factor this thing. All right. So this is a 4th degree polynomial. You've never been able to factor anything like this before. Okay? First step. So on a test, I will ask you to list the potential zeros. Okay? When I say potential zeros, it's just the numbers. So what are all the numbers that multiply to 12? Start with the 1, the easy one. 1 and 12, right? So you just go plus minus 1, plus minus 12. What else? 2 and 6, or 3 and 4. So plus minus 2, plus minus 6, plus minus 3, plus minus 4. That's your potential zeros. Does that make sense? Okay. If I ask for the potential factors, they don't here, but we might as well do it. So I'll say A2. List potential factors. I don't know what it is. A pi. Let's go with A pi. It doesn't really matter. So the potential factors are when you write it as brackets. So that's when you go x plus minus 1. I just made it up. So those are the potential factors. Of this group of 12 factors, there's actually 12 of them here because it's double, because it's plus or minus each one. You have to figure out which one actually is a factor. Now, the reality is, if this was actual life, you would have to test each one because there's no way to actually know until the remainder is 0. There's no hints, there's no anything like that. But Math 12 is rigged. Okay? So on a test, what I will do is I'll say, okay, list all the potential factors of this. You'll get a mark for listing them all. Then on the next step, I would narrow it down to 3 that you have to test. Okay? So that one of them actually is a factor. Okay? I'm not going to make you test 12. All right? And the bigger this number gets, the more factors you have, possible factors you have, right? So I would narrow it down to 3. But we're just going to say use x minus 1. That's what we're going to use, x minus 1. Which means our a value is?
1.
There you go. So a is equal to 1. All right. I'm going to do synthetic division because I know this one works. Okay? And we can get the remainder of 0 to validate it. So synthetic division, a value of 1. Do I have to add in any placeholders?
No.
No. 1, 2, negative 12. All right. Do the synthetic. Or long if you prefer long division. Done? This is why synthetic's so much better. There's your answer. Should have gotten a remainder of 0. So we write it as dq plus r. Our divisor was x minus 1. What's our quotient?
X cubed plus 3x squared minus 4x minus 12.
Exactly. It was a 4th degree that we divided by a linear, so it has to be a cubic. Okay. What? I think you're right. What'd you say? You do it again. All right, because we're factoring this. We don't know how to factor this cubic, so we have to do it again. Now, look at the constant term. It's the same as the one above it. So all the potential factors are the same. Okay? I'm not going to make you do it like on a test. I wouldn't make you list them all out again and then test. I would just tell you essentially. So we're going to use a is equal to 2. So if I say a is equal to 2, what's my factor that I'm using?
X minus 2.
X minus 2. So we're doing synthetic division again, but this time we're doing it on this one here. So 2 goes outside. Do I need a placeholder?
No.
No. All right, do it, please. Did you get a remainder of 0?
Yeah.
That's good. Why is that good? because it means it's a factor. Okay, we write it as P is equal to DQ plus R. Our divisor was x minus 2. I'm leaving some room there on purpose. The quotient, what's my quotient now? Yeah.
X squared plus 5x plus 6.
X squared plus 5x plus 6. Why did I leave room there? Yes, don't forget about the x minus 1, peoples. And the remainder is 0, so don't write anything. Are we done? Why?
There's still more to add.
Because you can factor it again, but what is it? It's a quadratic. Our old friend from grade 11. What multiplies to 6 and adds to 5? So it becomes x minus 1, x minus 2, x plus 2, and x minus 3. That is the factored form of the original. So if they said, which they will, plus 3. I'm just checking to make sure you're paying attention. If I say, what are the roots of the equation? You would tell me?
1 plus minus 2 and -3.
There you go. The roots are 1 plus minus 2 and -3. What makes each bracket 0? That's it. Yep.
So like when we're like writing that you want that like in order, I guess you could say like you want like instead of it being like when we're listing it, like x plus 3 and like x minus 1.
Oh, I don't care about the order.
Okay, how we do
No.
that. I guess.
Yeah, because you're just multiplying. It's irrelevant.
What about the possible zeros plus minus 6 and plus minus 12? Don't you talk about those?
Nope, because they don't work.
How do you know if they have
They don't work because we just factored it. I mean, you could try them. If you put an a value of 12 or divide it, you're going to get a remainder of something that's not 0. So they don't work. These are the only ones that work. Okay. Questions I would like you to do. So, go away. Number 1. So for number 1, use x plus 1. For number 2, use x minus 1. And for number 6, use x plus 2. Then, because it's a fourth degree, x plus 1. So you have to do it twice. Let me stop this recording and then I'll say something else. I'm going to